What you're looking at is an autonomously driven AI powered slot car that just participated in a 24-hour race. Pretty cool. But how did we get from this to this to this?
She won!
Yeah, she's driving. Woo!
Research. Lots and lots and lots of research. That was our group chat for 2 months.
It took us 8 weeks just to build the car. We didn't even collect our data set until the last day of the last full week. So we basically just did a ton of research. We found out what we would need parts wise, what kind of parts we could get, what would actually work with each other, what would work with the track. We needed, for example, a way to get the data onto our PC from the car, and we were suggested an SD card, but I tried to work on that for like 15 hours and it failed. So we actually ended up going with a better solution, which I'll tell you about in a second. So we need a way to get the data off the car. We need a microcontroller to run the AI. We needed a buck converter to convert the 12 always on volts from the track down to 5 volts for the ESP32. We needed to figure out what type of sensor we were even going to use. I thought about that for a while, thinking, what's the one variable that's going to change as the car goes around the track. And I thought about the angle of the blade. That's the part of the car that goes in the slots, and it has some brushes attached to it for the power pickup. So I thought if we put a little gyro sensor on there, that we could capture the angle of the turn. I didn't actually know how it worked. I thought it captured the actual angle, but it captures angular velocity, which turned out to be a good thing because it was just sort of referencing itself around the turns of the track. We didn't have to place it in any absolute position on the track every time for it to learn where it was on the track. I know maybe that sounds a little complicated. It was. So we got the sensor, we settled on the microcontroller, and we did the schematic, found out exactly, how much power our motor driver could handle, and so on. And so we got all that together. We built the car, and like I said, sorry, you can't really see that. Like I said, we had a heck of a time just gathering the data. And once you gather that data, let's see if I can bring this up. Yeah, so once you gather that data, This is what it looks like. Just numbers. You got your turn sections, and then you have your reading of the sensor right there. So that was 20 laps of data. We collected that last hour of the last day of the last full week, leaving us 1 day to train our AI. And so let me tell you what we did with that. So once we got the car figured out, we needed to have all the parts fit in the car, of course, and we needed it to run for 24 hours without blowing up. Those were our main considerations there. It certainly took a while, but once we figured that out and got the data collected, it was time to train our model. This was all of our final code, and so what we did was we used a program called TensorFlow to convert our data into tensors, which I believe that's what it came out looking like. I think that's the actual data. Yep. So we convert all the numbers from the raw data into a tensor, which is just another sort of 2D like array of numbers. It's a tensor. It's a 2D array of numbers. It looks like that. And we convert it, and then after we convert it to the tensor, we have track segments that represent the name of the track segment, the type of segment, and a throttle value. So basically we want to convert the data into a form the computer code can read, and then we train our model to recognize the track segments from the data. So it goes around and around and it makes a guess, and depending on how far off it is from being right, we adjust parameters called weights that will then tell the computer that you were wrong on this one, so guess again. And it keeps doing that in a neural network. It keeps going around, guessing, 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 until it's able to recognize, oh, that's a transition. I'd better put the throttle down to medium. That's a straight. I can jack it up here. So that whole process, it doesn't take more than a few minutes to train it. And then we trained the model, and then we had to have a way to get the model running. And I was actually able to figure out a pretty cool method of storing the model on your PC basically, and then going through the Wi-Fi and calling it up. So you can just run the model on your PC and then have it connect directly to the microcontroller. Trying to find that for you here. Yeah, you got your Wi-Fi credentials, your PC IP. Connects through there. Runs the drive loop and sends the data. So this is our main code here. And you have a page of code for your sensor, which comes with its own library. A page of code here to convert the TensorFlow Lite model into a form that the PC can read off the ESP32, so on and so forth. All this here, that's just for the motor controller. So this was a huge project. It was a lot to put together. I mean, you have to get this car to run for 24 hours straight. So, your wiring has to be good. Your power all has to match. Your AI just has to work reliably over that many hours. And we were able with this car to do 12,000 laps before our blade broke down at around 4 a.m. It was actually already a used blade. I'm surprised it made it that far. So that was good. I mean, we were pretty proud of ourselves for that one. Well, I think that's about it. Thanks for watching.